Assalamualaikum and hi! My name is HUDA binti NORIZAN with matrix number 157019 and my partner is...
Hi, my name is DINI binti ZAKI and my matrix number is 159111.
Together we will present about radiation in space. What is radiation in space? Space radiation is different from the kind of radiation that we experience here on Earth. It comprises of atoms in which electrons have been stripped away as the atom accelerates in interstellar space to speed approaching the speed of light. Eventually, only the nucleus of the atom will remain. Space radiation is made up of four kinds of radiation. Firstly is the particle that trapped in the Earth's magnetic field. Second is the particle that shot into the space during solar flares, also known as solar particle event. Thirdly is the galactic cosmic rays, and lastly is the UV radiation. Earth's biggest source of radiation is the sun. The radiation can be either non-ionizing or ionizing radiation. Ionizing radiation consists of particles that have enough energy to completely remove an electron from its orbit, and it will be creating a more positively charged atom. But non-ionizing radiation is less energetic, so it does not have enough energy to remove electron from the material it crosses. Galactic cosmic radiation, which also known as GCR, comes from outside the solar system, but primarily from within our Milky Way galaxy. GCR is composed of nuclei of atoms that have had their surrounding electrons stripped away and traveling at nearly the speed of light. Galactic cosmic rays are the slowly varying, highly energetic background source of energetic particles that constantly bombard Earth. GCR originate from the outside of the solar system and are likely formed by explosive events such as supernova. Next, one of the type of radiation in space is the particle that trapped in the Earth's magnetic field, which also known as Van Allen radiation belt. Particles trapped in the Earth's magnetic field refer to charged particles, mainly electron and proton, that are captured and held in place by the Earth's magnetic field. And these charged particles from the solar wind approach the Earth, they can get trapped in the magnetic field line and spiral along this line, creating the Van Allen radiation belt. The particles experience a magnetic force that keeps them constrained to move along the magnetic field line rather than escaping into space. Solar flare is an intense abrupt release of energy that occurs in the sun as the magnetic field changes due to the presence of flux or the movement of sunspots. Flares are our solar system's largest explosive event. They are seen as bright areas on the sun and they can last from minutes to hours. Solar flares and coronal mass ejection occur more frequently during periods of higher solar activity. As a result of this event, high-energy particles, which is the proton, electron, and alpha particles, are emitted, which can enter the Earth's atmosphere along the open magnetic field line. Solar energetic particles can reach all regions of near-Earth space, including the lunar surface, except for low-altitude and low-latitude Earth orbit, where the Earth's magnetic field is strong enough to form a protective barrier.
For non-ionizing radiation, we got UV or ultraviolet radiation, which is a type of energy from the sun that sits just beyond the violet end of the visible light spectrum. The sun is a source of full spectrum of ultraviolet radiation, which is commonly subdivided into UVA, UVB, and UVC. These are the classifications most used in earth sciences. UVC rays are the most harmful and are almost completely absorbed by our atmosphere, while for UVB rays are the harmful rays that can cause sunburn. Exposure to UVB rays increases the risk of DNA and other cellular damage in the living organism. Fortunately, about 95% of UVB rays are absorbed by ozone in the Earth's atmosphere. For example, the Hubble Space Telescope captured this image of Jupiter's aurora in ultraviolet wrapping around the Jupiter's North Pole like a lasso. This unusual false color image shows how the Earth glows in the UV light. The part of the Earth that facing the Sun reflects much UV light, and bands of UV emission are also apparent on the side that facing away from the Sun. These bands are the result of aurora caused by charged particles given off by the Sun. They spiral toward the Earth along the Earth magnetic field line. Moving on to the effect of radiation of space. Ionizing radiation hazard. Space is filled with ionizing radiation, primarily from the sun and other celestial bodies. This type of radiation has enough energy to ionize atoms and molecules, posing a risk to both humans and electronic equipment. Second, solar wind and cosmic rays. Solar wind composed of charged particles from the sun and cosmic rays, high energy particles from deep space, create a continuous radiation environment. Astronauts in space are exposed to higher level of cosmic rays than on Earth. Third, health risk for astronauts. Prolonged exposure to space radiation can increase the risk of cancer, cataracts, and other health issues for astronauts. Protective measures such as shielding and monitoring radiation level are crucial for long-duration space mission. Fourth, impact on electronics. Radiation in space can affect spacecraft and satellite. It can cause electronic components to malfunction or degrade over time. Engineers must design spacecraft with radiation-hardened material and technology to ensure mission success. And fifth, magnetic field as shield. Earth magnetic field acts as a shield against some space radiation. Deflect charged particles away from the planets. Spacecraft and habitats beyond Earth's protective magnetic field may require additional shielding for the safety of occupants. In conclusion, radiation in space presents formidable challenges for both human exploration and the operation of spacecraft and satellites. As we venture beyond Earth, the omnipresent hazard of solar wind, cosmic rays, and unpredictable space weather demand innovative solutions. The health risk posed to astronauts necessitates ongoing research into advanced shielding technologies and medical countermeasures. While Earth's magnetic field offers some protection, the complexities of space radiation require a comprehensive understanding and strategic preparation.